We are now moving on to our final keynote of Collaboration Workshop 2025. And I have been particularly excited about this one. One, because AI, it's something that's kind of been a theme throughout. Two, because Tom is joining us from Scottish Government, and they have had the Scottish theme throughout. So it's a pleasure to introduce Tom. Tom has been working for and with government organisations at various levels around the world. He has spent a decade developing and improving use of data to inform policy, strategy, and operational decisions. He has extensive hands-on experience working across data science, data analysis, data architecture, software development, and data engineering, and has provided technical advice to blue-chip companies and startups, as well as intergovernmental organizations. So, without further ado, I will hand over to Tom.
Thank you, Kyra, and I hope that that hasn't set expectations too high, but I am also aware that for those in the room, I've brought you in from outside in the sun. So I need to make sure it's quite good. Although for those who've come up from south of the border, I'm conscious that that's a chunk of the room. I presume quite a few people online. I have previously worked in UK government, played a role in professionalised science over the last decade, as well as all of that stuff sort of outside of the UK, before coming to Scotland and taking on the role of Chief Data Officer here. But the focus of my talk today is very much going to be from a Scottish perspective and a Scottish government perspective, which hopefully will have some relevance for the people in the room who work in Scotland, and will probably have some relevance for those who work outside of Scotland as well, because of the association with the UK level AI policy. Most importantly, I will try throughout to make it relevant to software development and to sustainable software development and software for research. Before getting too far into that promise, I emphasise I'm not a software developer, despite my blurred introduction. I've overseen software development projects. As far as data scientists go, I'd like to think I'm a pretty reasonable programmer, an object-oriented programmer, not just someone who writes scripts. But there will be definitely people in this room who will surpass my knowledge of software development. And despite the overall emphasis on AI, I hope everyone in the room will, as technicians, will appreciate when I say that before I can talk about AI, I should be talking about the foundations of AI, which is data. And I don't just say that as Chief Data Officer in Scotland. As I'll get to later on, apart from some quite narrow use cases, I don't think we'll get very far with the use of AI of any kind without having our data in good order first. In terms of what's going on in Scotland, which I think reflects what's going on at the UK level as well, data across the public sector, which often gets fed into research in our national safe havens, has kind of developed as separate islands, often with different ways of describing the same things, different languages, you could say. But what we've been seeing in Scotland through our various work on communities of practice and federation of data, and what we're starting to see at the UK level through the National Data Library Initiative, is efforts to try and translate between those different islands and make it so that data can pass between them and can be used together from those different areas of public service, which from a research perspective starts to mean that some of those questions that cross the boundaries of different collective action problems, different sort of issues that the government deals with, can be answered from multiple directions instead of being confined to the processes which are involved in government admin. Specifically in Scotland, I'll call out our maturity programme, which the UK has been copying, which has been helping to make sure that public sector organisations have an assessment of where they are in terms of their capabilities with data, not necessarily in the most sort of objective way, but in a way that they can then use to raise with their senior leaders some of their needs in order to get things in line. I should imagine this is a common story for universities where the leadership may well not come from a technical background, or certainly not from a data background, and helping them to appreciate what's needed in terms of investment, what's needed to get the organization to a place where it can make better systematic use of data instead of having data in isolated pockets. Now, in terms of AI supporting data reciprocally, we've got a few things going on in Scottish Government that we hope will integrate into the National Data Library exercise at the UK level. So, as well as trying to promote data cataloguing, taking a lesson from the research community and adopting the FAIR principles, trying to make the data findable, accessible, interoperable, and reusable, but making sure that we're not assuming all of that can sit in a single piece of infrastructure, and that the ability to share metadata between catalogues is what's really needed, rather than consolidating everything in one place. Within that cataloguing work, we're starting to test out the use of AI to, within particular data sets, profile the metadata, and through that give us a sense of quality, and also potentially generate metadata based on comparable data sets elsewhere to fill in the gaps. All of these are applications that have potential benefits for research projects using public sector data, because without having that metadata and that understanding of how the data has been generated and what can be done with it, obviously it's pretty hard to map that over into the research questions that are being answered. Beyond that, one of the major barriers for the reuse of data within the public sector, but also across the boundary into research, are the very necessary, of course, protections we have in place against breaches of personal privacy. So some of the issues there are cultural, where the balance of incentives for people who get left with decisions about data sharing aren't necessarily aligned with the public benefit. So there's a lot of downside as a data owner in government to letting your data be reused for someone else's purposes, which could be another area of government, another area of the public sector, or it could be for research projects. It's very hard for those data owners to see the benefits of that reuse of the data. So as well as keeping better track of lineage, so that there can be a bit more attribution for where the data has come from when it's used in other tasks or in research, we're also trying to attack that culture issue and try and bring down some of the incentives barriers for using data. Now, where AI plays a role in that is among a number of different emerging tech components in some of our use of privacy enhancing technology to make sure that data can be used across boundaries without needing to be shared in its raw form. So various cryptographic techniques allow us to ask questions of data or ask questions of derived kind of features of the data without sharing the raw data, or pass messages between multiple parties that have information added to them without the raw data being added, all of which then allows questions to be answered without the raw data being shared. Now, at the moment, the research use of data tends to rely heavily on safe havens and a lot of quite rigorous protocols around the researchers who are allowed to touch the data. The promises of privacy enhancing technologies is that that might reassure some of the stakeholders to the point where it can bring down some of those restrictions, make it easier for researchers to bring public data, bring administrative data into their research projects. Conversely, I'm hoping we can make more use of the safe haven infrastructure in order to prototype some uses of AI machine learning for public services that can then be prototyped with a small team up to the point where a value is being demonstrated, so that we can then build them with privacy enhancing technology to run in a much less secure environment than the safe havens. The other way in which we're using this technology is working with the Open Government team in Scotland. We're trying to develop tools that make it easier to do quality public participation around questions of data sharing, data reuse, and AI, so that we can reassure the people responsible for agreeing to share data that there is a public acceptability in what's being done, that there's a public interest in that particular use of the data. Now we're talking to Research Data Scotland, one of the entities in Scotland that's involved in that process of giving researchers access to data, working with our National Safe Haven here, which is integrated with some of the high performance computing infrastructure for the country. We're working with them as one of the potential use cases of this technology to test the acceptability of particular use of data. And so that could have knock-on effects for the potential reuse of administrative data, of government data in research projects. And then lastly, in order to help raise the capability of the public sector as a whole, we've been trying to bring everyone together over a shared vision that can help inform the conversations people are having with their leaders. And this is work involved not only public sector staff, but also people from the private sector and from the third sector to help make sure that in the way we were shaping that vision, we weren't just thinking about the sector, but the whole country. The vision that we came to after a number of workshops was pretty uncontroversial, but layered around that, that sort of core intent of Scotland's data advancing innovation and well-being for people and for the planet, in line with the sustainability theme here. We laid around that a number of deeper ambitions to help make sure that regardless of how flexible organizations were to buy into that vision and put it at the center of their own strategies, they could choose more or fewer layers from this vision. And you'll see that environmental benefit is prime among those. So in your terms, that should hopefully mean that, again, in terms of research uses of public data, more data becoming available from the public sector, but consideration of the environmental repercussions of that as part of the processes that come down from those strategies being formed. And then we're now at the phase of bringing all of this into practice, again with a mixed group from across sectors in Scotland, in leadership and technical roles in various organisations, helping to translate that vision into materials that can be used by different organisations. So, having talked about data as a foundation to AI, I'll now get into the main event. I'm conscious that in the room there will also be people who do this as their day job, optimizing machine learning algorithms for various infrastructure. So I'll not pretend to be the greatest authority in the room. Some of this may be teaching grandma to suck eggs, but I'm also conscious, there'll be people in the room who are doing all kinds of other analyses, statistical analyses, who may not be au fait with AI in all its various forms. So I'll try and sort of speak from an introductory level, and I hope no one finds that too slow. Now, crucially, when I'm talking about AI, that can mean a whole swathe of different things to different people. The term is used pretty nebulously. In my career in government, I've had a lot of people try and sell me a lot of different things as AI. The vast majority of it that I wouldn't consider AI. Some of it, I remember there was a major contractor who very proudly came to show me a Python script one of their interns had written to scrape data from our own website, which obviously we had a structured database for behind the scenes. So I don't know how no one involved in the process of pitching to come and tell me this hadn't understood, the basics of digital infrastructure. But suffice to say, they were very proud of their AI, and I had to very gently tell them that this wasn't necessarily what we wanted, but if they could go away and do something much more useful, then more centrally within that cloud of things we could be calling AI, we start to get into some broader and more definitive categories. So machine learning is by far the most prominent at the moment, and within that, it tends to be generative AI and large language models, and even ChatGPT specifically, that have the public very excited and are getting all the attention. And the vast majority of times people talk about AI at the moment, they're talking about this, probably large language models, or even specifically ChatGPT. And I even catch myself saying AI when really I should be saying generative AI, Gen AI. Generally, the use cases for this stuff are still developing. There are quite mature use cases for other areas of machine learning, like machine vision, and I'll give some examples of this in a second. And then there's a whole vast array of different machine learning techniques, which, for those who aren't a regular user of machine learning in the room, essentially means finding patterns in data that can be used to predict things about that data, whether it's data that hasn't been collected yet or reproducing categories that people have applied to it elsewhere. I mean, it is a lot like regular statistics, and if you were to force me to draw a line around it, I'd say it's automated model selection or feature generation, rather than as social scientists might do, choosing features and a specific set of features for their model upfront. I imagine a lot of people in this room, that distinction's redundant because you only do some form of automated model selection. That being said, machine learning is not the only kind of AI, and previous decades and perhaps in future decades, there are quite disconnected disciplines that have received more attention by people talking about AI. Symbolic AI, focused on trying to give computers all of the logical rules they might need to reconstruct human thinking, was previously sort of a focus of the AI community before certain technologies, thanks to sort of computing power, became more effective. Causal AI has been developing in parallel to machine learning approaches, and with sort of quite different ideas and origins, and may come more into vogue in the future, particularly because of some of the limitations of machine learning, which I'll get onto in a second. Now, again, some of this may be redundant for the room, but before I get into any of those criticisms, I do want to emphasize how amazing the possibilities seem to be for AI and even specifically generative AI. We've seen Nobel Prizes awarded recently around some of the work done with very carefully designed, expert designed tools that use generative AI use machine learning for identifying patterns that help predict effective protein folding, very, very quickly getting us from a place where we had a relatively small proportion of all the naturally occurring proteins actually modeled structurally to a place where we have all of them. And alongside that, development of generative AI tools that now let us predict viable protein foldings that we've not seen before, which potentially could have all kinds of applications in drug design and medicine. We've also started to see systematic evidence demonstrating the value of AI tools for things like material discovery. Now, a key message here is that this isn't a substitute for the researchers involved in material science. What was found by this study was that it was the most productive researchers who saw the greatest gain in productivity from using these tools, although they also saw a reduction in job satisfaction, which needs to be considered in the deployment. We've also seen high-profile news stories recently about generative AI that's been designed, in this case by Google, to purposefully be a research tool, seemingly matching humans' ability to suggest hypotheses for disease mechanics. We've also seen maybe more anecdotal accounts of large language models interpolating between disparate fields of science. So where two disparate disciplines might be talking in similar terms, might be using similar maths, but no person has had the time to actually read either of these disciplines in enough depth to see the links. The fact that large language models have been trained on a huge volume of data, to all intents and purposes, all of the internet, means that they're in a position to connect research that no person could have read. And at the same time, as well as all of these amazing opportunities that seem to be arising from generative AI and from large language models, my reading of the research is overwhelmingly that these tools are not a replacement for people, regardless of what we're being told by Elon Musk and other tech bros. Where there is systematic evidence, we're seeing the story that they are a very valuable tool. Sometimes a more modest tool. For example, in a study between Microsoft and Accenture, we see that experienced software developers are not a significant productivity gain from using I think it was GitHub Copilot to help with their programming. Now that's a productivity gain measured in terms of commits, I think it was, and pull requests. For more junior software developers, there does seem to be a significant gain in terms of productivity as defined that way. But for Accenture, at least, we see a significant increase in build failures. So the story seems to be one of increased output at the expense of the quality of the code. Well, that would be one interpretation at least. And anecdotally, this chimes with what I tend to hear, which is that a lot of the time that's being gained through having the code automatically generated is then lost again in terms of correcting the error that it's introduced. I suppose my take on it all is that where I've experimented with these tools, it feels a lot like one might use Stack Overflow, gives you a starting point, maybe better than you'd get from just searching for something on the internet. But there's then still a lot of adaptation to make it fit your purposes. And what it's a long way from doing, as far as I can tell, is reproducing the architecture of a program, sort of a number of classes that interact in a sort of systemic way to serve a particular purpose. I talked to someone from GitHub about this at an event a while ago, and they made the case well, but the body of data GitHub has does include lots of object-oriented code bases, and probably much more than natural language corpuses, has that kind of structure of a number of different entities that can interact in a particular way. So there's probably more promise there than elsewhere of reproducing that idea of different entities interacting in a particular way. But so far, in terms of systematic evidence, I don't think we're seeing the suggestion that it is a proper replacement for human software developers, much as I've heard business leaders say they're expecting to sack all of their software developers. Some business leaders, by no means all. Another sort of popular example of the hype around generative AI and large language models has been sort of leading proponents talking about their reasoning capabilities and their ability to perform very well on exams, even maths exams. There was a paper from Apple Research in the last 6 months that demonstrated that departures from sort of the typical maths problems in those exams saw the large language models then drop off dramatically in performance. So as we'd seen in previous generations of GPT and GPT-3, where it was assessed not in the way that the machine learning research community tried to assess it, but in the way that cognitive psychology assesses people, we'd see that for reasoning, in terms of a causal understanding of the world, or in terms of logical problems that don't fit precisely the sort of classic kind of logic problems that you get on psychology tests and on the internet, that they just didn't perform at all, even though they perform incredibly well at other tasks, and potentially well beyond human capability. So it's important when we hear about AI reasoning that we recognize that that might not be reasoning in the way that we think of people reasoning. I'll expand on that in a second. And then we've also, in the last 6 months, heard more rumor, more leaks around the sort of latest generation of large language models not meeting the benchmarks that have been set internally. So even where the deep learning research community are setting the targets, those aren't necessarily being met. And there's some general discussion about sort of plateauing performance for large language models, even with more investment of resources. Why is this? Well, harking back to that cognitive psychology research I mentioned, compared to humans, and I'll add that this gets reinforced by talking to some, at least, researchers actually in the AI space. You can roughly think of the capabilities of large language models akin to the description that's popular in behavioral sciences of people thinking fast and slow. And essentially, large language models and generative AI are very, very good at thinking fast, and far, far better than people are. But they cannot think slow at all. Now, if we think about generative AI, large language models performing very well on medical exams or law exams, these are a good example of where we use fast thinking, someone's ability to reproduce quite technical information under pressure in a short sort of space of time as a proxy for their underlying knowledge. And then we don't immediately let those lawyers or doctors go and practice that job until they've demonstrated that they can put that into practice over some time, demonstrated that it is understanding and not just rote learning that they've picked up from their training. So although we hear a lot about large language models, sort of passing exams at expert levels, we need to remember that's one part of human reasoning. That's the fast thinking. And in their case, it's not a proxy for their ability to then apply that knowledge in the real world. So what that translates to is uncertainty, because although I'm keen to stress that these are not a substitute for people. People's day-to-day jobs are probably a complicated mix of fast thinking and slow thinking, and I'm not sure we have any systematic audits for any jobs of how long people are thinking fast, how long they're thinking slow, how often they're switching between those two modes of thinking. So to design where we can plug an AI component into that flow and have someone switch to a tool, use the tool, and then go back to thinking slowly is a major design challenge. And so it becomes quite hard to assess what the economic impact of these technologies is going to be. And it's likely going to be quite a while before we see their full impact roll out because of the challenge with working out how we fit them around our lives. I think user-centered design is going to be essential in that process alongside the underpinning data I talked about before. We need to systematically understand jobs before we can work out where we use these tools. In terms of AI in Scotland, the Scottish AI strategy was launched back in 2021, long before the recent excitement around AI. Its emphasis from the start has been trustworthy, ethical, and inclusive AI. Although AI ethics can be tricky and can often descend into a bit of navel gazing, it has resulted in a number of practical outputs that help confront some of the ethical challenges around AI. The repercussions of these for the research community, I'll get into as I go through them. So crucially, the AI register, which became mandatory last year, is a public record of wherever AI is being used in the public sector in Scotland. Now, for research purposes, that doesn't mean that every experimental use of machine learning needs to be declared publicly, but it does mean that as machine learning models go from a research phase into implementation, into use in the public sector, they need to be documented in a way that can be understood in the AI register. And luckily, behind the register is a suite of tools developed through a commercial challenge to help manage risks, to help identify risks, and that suite of tools is now being picked up by Microsoft. So in terms of getting a critical mass for that approach to understanding the risks and mitigations around them for AI, it feels very likely that that use in the Microsoft suite and Azure will make sure that that approach to kind of describing the risks and the mitigations gains much broader traction. We also have a Living with AI online course available for everyone in Scotland, or indeed beyond Scotland, to help the general public grapple with some of the challenges around misinformation and hype with AI, to help try and ground some of that and put them in a place where they can make sensible life decisions about the implications. The AI playbook is targeted at businesses and particularly SMEs that aren't in the AI world, that need to understand the implications for their operations. And we're also running, as I alluded to before, participation exercises to help understand public views on AI in general, but also particular uses of AI by the public. And as I said before, some of the technology that we're developing to support that could play a part in some of the decisions around research uses of AI and data. In terms of some of the practical uses we've seen, again, this might be really obvious to those in the room who've been involved in AI use cases and not at all to others. I talked about the broad category of machine learning before and sort of statistical pattern recognition. We see that put into practice a lot in healthcare. So, for example, around chronic obstructive pulmonary disease, NHS Greater Glasgow and Clyde have demonstrated the value in triaging patients and redirecting them for imaging, for investigation. But we also, in entirely separate fields, see machine learning useful as well, where Transport Scotland, for example, uses it to help predict road maintenance needs by bringing together data about weather conditions with sensor data to identify situations where maintenance is likely to be needed. Machine vision I mentioned before as well, which is applying those same statistical pattern recognition principles from machine learning specifically to image data. Could be still images, it could be moving images, and across Scotland, maybe obviously we see great applications of that by the NHS trusts, particularly around imagery, where we see it play a role in triaging images for further investigation. So back to that point about the human AI team, this is not a substitute for radiologists, but radiologists are in short supply, let's say, compared to the potential need, and helping direct their time as effectively as possible is obviously a really valuable service. The AI might be able to spot in an image some hint of a disease based on an experience of viewing more X-rays than any human could possibly have done, and comparing those to the medical record of their outcomes. But with no understanding of the underlying physiology, it of course then takes a doctor to understand what the implications of a tumour in a particular place might be, to understand how to take things forward. On the again, very different sort of domain, we've seen Marine Scotland making use of machine vision to identify different species of fish in a number of different contexts, whether under the water with cameras or on conveyor belts in trawlers. All of this helping us to understand the health of our marine environment. And then maybe illustrating the pyramid of mature use cases between these different kinds of AI and different kinds of machine learning. When we start talking about large language models, there aren't so many use cases in the public sector. The government has been very actively exploring a number of use cases. In terms of deployed use cases, we have one that I'm aware of in Scotland, again through a commercial challenge we ran, and this was helping to make information about product services more accessible to people with disabilities, a multimodal AI that combined general machine learning for triaging cases that were coming in with a generative AI chatbot to help people have a natural exchange about what they're experiencing. Now, the UK in January launched its AI action plan, which had some very welcome elements in it, but given the sort of fiscal state of the public sector at the moment, what it didn't include was a lot of money allocated to AI. What it did include was the plan to leverage private sector investment to help fund public benefit. And so through the AI Growth Zones initiative, which is running at the moment, selecting AI Growth Zones across the UK, the intent is to use some of the private capital that's out there that's interested in building up data infrastructure specifically for AI, with some strings attached to kind of help piggyback on that growth for the ecosystem around that. There was also in the UK's AI action plan more positive action on regulation, where we in Scottish Government have been pushing the UK for some time to make sure that regulators in the UK were properly equipped to support businesses trying to innovate with AI. We've seen more commitments to funding there. We also saw an emphasis on public sector adoption, and as I said, we are seeing quite a lot being done across government in the UK, exploring different use cases of large language models of generative AI. And I was glad to see the acknowledgement of the importance of data and the National Data Library Initiative that I mentioned before as one of the foundations for seeing that public sector use. Last of all, in terms of how to apply AI, there was an emphasis on looking outward, trying to understand the emerging technology, but to my mind, not enough looking inwards to systematically identify use cases. And I think there is a role for research in general to play in the pipeline of potential uses for the public sector, where once they've been identified by the people who are doing the public sector jobs on the ground, the public sector itself doesn't have the capacity, the technical capacity to explore all the possible uses, and that's where support from research and input from experts outside, whether in terms of the choice of algorithms or in terms of the implementation through software. And then last of all, thinking about how Scotland will go forwards in terms of AI, we made a commitment last week to a national transformation around AI in partnership with businesses and with academia. I expect this will be joined up with our green data centre strategy, and I expect with the advent of more efficient approaches to generative AI, we might see small data centres involved in that as well as big ones. It's going to continue to emphasise supporting SMEs with AI, not just unicorns, as well as more of those skills within government. Although I emphasise there's never going to be enough of the technical skills in government without drawing on the research community as well. And then last of all, I'm keen that as we redevelop our AI strategy, as the 2021 strategy starts to come to an end, that we look out to all of the great research going on across Scotland, both in terms of applications of AI, but also in terms of some of the supporting technologies that might make it greener and more sustainable. And that's everything.
Thank you, Tom. The questions are pretty much flying in, so I hope you're ready. I guess appreciate the fact that you've mentioned, what Scottish Government are doing, particularly around the strategy. And someone in the room has asked, in terms of us as a community, so thinking about the fact that a lot of us work in research software or research data, what can we do to help an AI-intensive future to be more reliable and trustworthy?
I think is an excellent question. And on the theme of this conference today, I think even at the research stage, making sure that the way in which AI is being implemented is done with minimal duplication, maximum reusability and reproducibility is critical. I think involving the experts in high performance computing from the research community as early as possible. I hope they don't resent me saying that in research makes sense to make sure that the way in which AI tools are being brought together is going in as efficient a way as possible. Will help make sure that the environmental impacts are sort of minimal. We saw just before this a demonstration of tools to help with the scheduling of jobs. Machine learning jobs can be very intensive in terms of computing, in terms of energy, and helping and thinking actively about when to run them, as well as optimizing the way in which they're implemented, is all going to help make sure that the knock-on effects for society are minimized. All that being said, in a lot of the conversations around the environmental impacts of AI, on the opposite side of the scales from the energy cost is the promise of AI for helping solve some of the big environmental and other existential challenges that we face. And so, as a research community and the people supporting a research community, I would encourage no one to, tie their hands too much, worrying about the environmental costs, because I think compared to all of the people generating lots of images and using ChatGPT as a search engine for their library times, things like that, anything being done with AI by this community is probably going to have more public value than a lot of what's being done with AI so far. And beyond that, in terms of ethical guidelines, something I didn't mention is the intellectual property implications of AI, that some of the widely available AI tools still have a lot of uncertainty over the rights to the data they consumed, fundamental uncertainty about what data they consumed in order to train their models. I'm sure there will be legal precedents set in the future, but for now, I think it's important to just be mindful that if you're using these tools, what you get out of them might essentially be somebody else's intellectual property. And for research purposes, obviously that's a serious consideration in terms of what could wind up inadvertently being plagiarism if you get back something which turns out to be a verbatim reproduction of something which is in somebody else's research. That's probably the main points I'd hit there.
Great, thank you. We've also got a couple of questions that have come in around the Copilot saving 29 minutes a day. So someone's asked, how big is the variability? In particular, does it cost time to some people? They're also curious about what task does it save time on. Someone else has mentioned that their workplace did try to bring it in, or at least tested it and rejected it. So they asked if you could share a citation on that.
It's a very reasonable question. I think rather than sharing a citation, what I will say is I agree that that's not the universal story. That's one systematic investigation within government. I've heard other pilots come back with different results, different balances of cost and benefit. I think an abiding theme is the value of these tools for people with accessibility issues. And I've heard anecdotally stories as well of benefits to people who find it difficult to communicate what they want to communicate otherwise. So maybe don't fixate too much on that specific number, but recognize that there are at least some systematic efforts to assess these tools which suggest that they have productivity benefits. There's still very much some open questions there.
Great, thank you. We have another question here around your view of AI. At least it feels it's a little bit more cautious compared to maybe what the UK government might be. So this person specifically said that the UK government might find that AI could do the job of civil servants better and for less money. How does that idea in particular compare to your opinion as well as the Scottish government's sort of opinion and thinking?
So if I come across as negative on AI, consider it more cautious. I think we're still in a process of gathering systematic evidence about what these tools can help with, what they can't help with. I'm sure in some sort of sources, people associated with the UK government may have made suggestions of possible efficiency gains. I don't think there is enough evidence to make any of those assessments so far. I think much as the UK government advises the civil service, we should be in a phase of exploration of these tools, active exploration, so long as it doesn't compromise data security, doesn't compromise any sensitive data, so that we can start to learn through collective experience where the benefits are. So, as I said in my last question, there are systematic efforts to assess these technologies, but we're far from being able to make decisive statements about to what extent they can fill in for people. And calling back to what I was saying about fast thinking and slow thinking, I'd emphasize without a technological leap, I don't think these tools are a substitute for a person in entirety. what we need to understand is which bits of each person's job they can do. And I suspect that will often be the most mundane bits of people's job that they don't particularly like themselves, and will often leave them to do more of the creative and problem-solving aspects of their jobs that they very likely enjoy more.
Great, thank you. Yeah, I'm finding it almost quite difficult because there's just so many questions coming in, and you're doing a great job to almost answer quite a few at a time. Let's see, maybe time for one more, if that's okay with you. Someone else has also mentioned this kind of stems from your previous answer. Well, they said, thank you very much for level-headed assessment of pros and cons. So there's that. And they have said, how can we now get that kind of thinking about AI into the heads of political decision makers, at least in Europe? As you can see, the room, we're all just trying to solve all world problems. So any final advice, I suppose?
So I think anything that the research community can do to help with that generation of systematic evidence is valuable in that exercise of helping political decision makers, official decision makers, and the general public grapple with this collective problem we have of using this technology to best effect. And I'm confident there will be incredible implications for what we can do as a society, much as we've already seen with things like AlphaFold. At the same time, we rush to decisions about it, as I've heard about anecdotally, with sort of people laid off, where companies assumed too quickly that this technology could be a substitute for their skills. There could also be dire consequences. So I think it's beholden of all of us to work together to, in a level-headed way, understand what we can get from this technology.
Great, thank you. I think we can leave it there. Thank you very much, Tom. It was fantastic to have you here.